Okay, so today I will show you a very simple project for beginners using the Arduino UNO, 4 buttons and one OLED display. And when I press the button, you can see that the graphics on the OLED display changes, and when I release the button, now the button is glowing. And of course I can also do this with the other buttons and keep clicking all day long. And as you can see, they are all shining and glowing. And that's because those are not ordinary push buttons, but they also include the LED light. So if I turn the switch around, you can see that there are those very small pins labeled plus and minus, and if I provide enough voltage, the LED will be shining. And the thing that I like about those buttons the most is that they are breadboard friendly, meaning that I can push those inside a breadboard and still have access to all those pins, which means that I don't have to design a custom PCB, at least not for the prototyping stage. But if you do need a custom PCB, you should definitely check out PCBWay, who is a sponsor of today's video, and if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping. And not only you can get PCBs, but also CNC machining, 3D printing and other types of manufacturing. So thank you PCBWay, and let's get back to our project. So again, I'm using the Arduino UNO, the 4 LED buttons and one OLED display, but the good news is that you don't need to have any of that. And that's because before running it on the real Arduino, I will start in the Walkway, which is a free online Arduino emulator. And in here, I will select a new project using the Arduino UNO. So I will scroll down and create a new project from scratch using the Arduino UNO. You can add a lot of different components, but unfortunately the LED button is not one of them. So what I will do is I will add a standard push button. And then I will add a standard LED, and let's just pretend that those two are one component, being the LED button. Now I want to connect the button to the digital pins up here, and so I have the real Arduino board rotated. I can do the same thing by selecting the Arduino board and pressing the R on my keyboard, actually pressing it twice to rotate it like this. And then I will also rotate the button, for example like this, and move it around here. I want to connect the button to one of those pins to get the state of the button, and I want to also connect the LED to one of those pins to actually set the state of the LED. Let's just make it somehow logical, so I will connect the anode of the LED to pin, for example, number 2, and the pin of the button to pin number 3. Now for the button itself, if I open the documentation, you can see that those long legs are always connected, and when you press the button, you will connect those short sides, meaning you will connect this to this or this to this. So I want to connect this one to ground, and ground is, for example, up here, so connect this to ground. And I also want to connect the LED to ground as well, so connect it to ground up here. When I press the button, I want to get the state of the button, and I guess there should be something in the documentation. So if I scroll down, there's, for example, this example, so I'll open it in Walkway, and it seems like that we have to first call the pin mode function to set the mode of the pin, and then we can read the value using the digital read function. I will also copy the define because I want the pin to be defined like this as well. So in here I will paste the define, but I will rename it to button down pin because I will have 4 different buttons, and button down pin is pin number 3. Then I want to set the pin mode, so I'll copy this into our setup function. For the button down pin, I will set the mode to input pull up, and it means that if nothing is being connected to this pin will be high, and if I then press the button and connect it to the ground, the state of the button will be low. Finally, I want to read the value, so I'll copy this line. So inside the loop function, I want to read the value of the digital read, and the pin is button down pin, and that should be enough for reading the value of the pin, reading the state of the button. If I run the simulation and press the button, obviously nothing is happening because we are reading the value of the button, but we are not doing anything with this value. So let's continue with the LED. I will again select it and open the documentation. And there should also be an example. It's actually this blink example, which is a default sketch for Arduino. And in here we have to also call the pin mode, but this time we will set it to output. So I'll copy this pin mode into our setup function, and let's create a new define, and that will be button down LED. In our case, the LED is connected to pin number 2, so I will change this to 2. And for button down LED, I will set the pin mode to output. Then I can set the pin state by calling the digital write either to high or low. So I will call digital write of our button down LED and set it to same thing as the value. If I play the simulation now, the LED is shining all the time. And that's again because we have the button set to input pull up, which means that if the button is not being pressed, the pin number 3 is reporting high state. So high state for the LED means it should be shining. And if I press the button, now it's not shining because now the button is reporting low state, and low state for LED means it's not shining. So let me just switch things around by setting this to inverse of the value. And if I restart the simulation now, the LED is not shining, but when I press the button, it is shining. And again, just imagine that the LED is part of the button and the button itself is shining. Before running this on the real Arduino, let's make a few tweaks. For example, we have everything connected to the ground, which results in very long wires. So for simplicity, we can also press this plus button and there should be a ground symbol like here. So we can use this instead of connecting it to the ground. For a real project, we will not use this ground pin, but most likely have one common pin for ground on the breadboard. So I'll connect it like this. And for the LED, it might be a good idea to add the resistor. I mean, for this simulation, it makes no difference, but for the real Arduino, it might be beneficial to have the resistor in here. So I'll add the resistor and also rotate it by pressing the R on the keyboard, move it down below the LED, connect the LED to resistor, and then add one more ground and connect the resistor to the ground. So I think that now our sketch looks much cleaner. For the real project, I'm using this small breadboard and also this small holder, which holds the Arduino UNO as well as the breadboard in the same place. This is 3D printed and I believe that you can download the print files and print it by yourself. I'll put the link down in the description. I will connect the button on the breadboard in a way that the plus pin for the LED will be closer to the Arduino board, and then connect the LED to pin number 2, the button to pin number 3, and LED minus to ground using the resistor. This one is, I believe, 150 ohms, and then connect also the right side of the button to ground. And I'm using this common ground row on the breadboard, so I also have to connect this to the actual ground on the Arduino board. So once I have everything connected, I can jump to the Arduino IDE. And in here, paste the code from the walk with sketch and select the correct board, in my case that's Arduino UNO, and hit the upload button. And so now when you press the button should be shining, and when you not press it, it should not be shining. And this will be useful later on because we would like to show a different graphics on the OLED display based on the button state. But for now I would like to do something different, and that is to use this button as a toggle button. Meaning if I press the button once it will be shining, and if I press the button again it will not be shining, and so on and so on. And it should be simple as well, we just need to keep the state of the LED as a new variable, and we also want to keep the previous state of the button. So let's go back into the book with sketch and create a few new variables, and let's start with this value variable and give it some meaningful name. For example, let's call this button down state, and then use it to assign the value of the button as well as set the value of the LED. We want to keep the track of the previous state of the button, so let's just call this button down state previous, and one more that will be the LED state, so button down LED state. Again, when the button is unpressed, the pin 3 is high, and when the button is pressed, the pin 3 is low. And we only want to change the state of the LED of the backlight when first the button was pressed and then it's unpressed, so the previous state will be low. So if the previous state is low and the current state is high, in that case we want to switch the state of the LED, so the LED state equals the inverse of the LED state, and then we want to digital write of this LED state to our LED, so we will use this button down LED state. The only missing piece is make sure that the previous state is set to the current state after we do everything, and just in case let's just predefine those variables with some default values. So the down state will be high because it's unpressed, the previous state is high as well, and the LED should not be shining, so it will be low. And let's restart the simulation. So the LED is not shining, and when I press the button it is shining, and when I press it again it should not be shining. However, you can see that that's not always the case. Sometimes it's just not changing the state, and that's because what's happening is when you press the button, the circuit opens and closes multiple times, which is called bouncing, and it will actually solve by itself once we add the OLED screen. For now we can just do it by adding a little bit of delay, so let's just call a delay, for example 50 milliseconds, and that will make sure that during those 50 milliseconds it will not read the state of the button. So if I restart the simulation one more time, you can see that now every click results in changing the state of the LED. And so when I copy this into the Arduino IDE and upload it to the real Arduino, I should see the same result. When I press the button it is glowing, and when I press it again it is not glowing. And of course if I keep pressing the button, it toggles between the on and off state of the LED inside. And since one button is working just fine, I think that we can also add the other 3 buttons. Inside the Walkway emulator we can select multiple elements with the shift key being pressed and then copy paste it. And let me actually do that 3 more times. And then we want to connect those to some empty digital pins. For example, the second LED could be connected to pin 5 and the button to pin 6. The third LED could be connected to pin 8 and third button to pin 9. And finally last LED connected to pin 11 and last button connected to pin 12. Now when you have the wire selected, you can change the color up here, so let me give them some different colors. Also, I've set the label to the buttons, and that could be done in the diagram.json file. So let's just call this button left, the other one will be up, and the last one will be right. Inside our code, we need to copy and paste everything 3 more times, so it will be defined for button left, button up, and button right. And let's set the correct pins. So the left button is pin number 6, LED is pin number 5, the up button is pin number 9, the LED is pin number 8, and the right button is pin number 12, and the LED is pin number 11. I will also copy those variables and change the names accordingly. We need to set all the pins in the setup function. And then of course read the states inside the loop function. And finally toggle the LED state upon clicking the button. And if you are thinking that this could be probably better done with arrays, you are probably right. Anyway, I've noticed one problem. This symbol alone means bit end, and we want a proper end, so we need to put it there twice. So I will update all those if statements and then restart the simulation. And once this is running, I can click on the individual buttons and turn on or off the individual LEDs. So I think that we can try it on the real Arduino. I will again paste the code into the Arduino IDE and upload it to the Arduino board. As you can see, I have all 4 buttons connected, so I can click on those and it should work in the very same way as on the Walkway emulator. So let's make things more interesting by adding this OLED display. And as you've already seen in the beginning of the video, I want to show images of 4 arrows. And when I click the physical buttons, I want to also update those images on the OLED display. Now this display is SSD1306 with the resolution of 128 by 64 pixels I2C connection. This one is sized around 1.5 inch, but I also have the smaller one. This one is 0.9 inch. And I also have a bigger one. This one is 2.5 inches. Now, since all of those are using the same chip and have the same resolution and connection, I can just use any of those. So let's jump back to Walkway, and the nice thing is that the emulator supports this OLED display. If I open the plus button, you can see I have this SSD1306 OLED display that I can use. Another nice thing is that I have plenty of videos describing how to use this display. For example, this one, which is called Image to OLED in 60 seconds. And if I open this Walkway sketch and run it, you can see I have this display connected to the Arduino UNO, and I'm just showing a full screen image. And despite the sketch being quite big, there's actually very little happening in here. So I'm using the U8G2 library, so I have to include it. And then initialize the display. Again, SSD1306, 128 by 64 pixel resolution using the hardware I2C connection. This is the array generated for this full screen image. And down here, I'm just calling the begin function in the setup function, clearing the buffer, drawing the image, and sending the buffer to the display. So we will do something similar in our sketch, but instead of drawing a full screen image, we will just draw 4 smaller images for individual arrows. And so the first step will be actually creating those images. And for that, I will be using Photopea, which is a free online graphic editor similar to Photoshop, and create a new file in the size 128 by 64 pixels, having the black background. Hit the create button, and this is our canvas. I will create a new layer by clicking this new layer icon, and then I want to draw those arrows. And there are many different ways how to do that. I will use the simplest one, which is using the pen tool. I will right click the brush tool and select the pencil tool, set the size to only 1 pixel, click this icon to make colors black and white, and then this one to swap it, so now the foreground color is white color. And I can start drawing. Now if I want to draw a line between 2 points, I can click anywhere, then press the shift key and click on the second point, and that will draw in a line. And just coincidentally, I was able to draw a line in the 45-degree angle. But I feel like this is too long, so I will select the eraser tool, set the mode to pencil tool, size to 1 pixel, and delete few of those pixels, for example, like this. Then maybe draw a pixel here and pixel there, and try to somehow connect this shape together, so something like this. And I can probably also use the fill bucket tool, which is hidden behind this gradient. So right click and select paint bucket tool, uncheck the anti-aliasing, make sure that the continuous is set to on, and then click inside this shape, and that will fill it. I will create a copy by right clicking the layer and selecting duplicate layer, move it to the right side, select edit, transform, flip horizontally, move it next to the arrow, like so, and then select both layers and merge those using the layer merge layers, and finally use the pencil tool to draw the bottom piece, maybe like so. And then of course fill it and maybe make it even bigger. Now I feel like that maybe this arrow is way too big, so I'll make it slightly smaller by deleting some of those pixels, again using the eraser tool. And this size is probably fine. I want to create this 1 pixel outline, and I can probably load the transparency of the layer by clicking the Ctrl key on my keyboard and then clicking the thumbnail, and then selecting menu select, modify, expand by 1 pixel, create a new layer and select edit, stroke, 1 pixel on the outside, but as you can see it creates an anti-aliased stroke, so maybe a better way will be to just create a new layer and then use the same pencil tool to draw those outlines. Again, I can click one point, then hold the shift key on my keyboard and draw a second point to draw a line. And I want this line to be offset on the bottom, so it's just like a skewed view of the icon. So I'll first draw the outline like this, and also on the bottom, and then use the selection tool and select this outline and move it by 3 pixels to the bottom by pressing the down arrow key on the keyboard. And then use the pencil tool to connect those pieces together. I can add a little bit of rounding by deleting some of the corner pixels, again using the eraser tool, so I'll maybe delete this pixel, those corner pixels, and maybe for those corner pixels I'll actually make it even bigger by adding this pixel and deleting those 2 pixels. So I think that the up arrow looks fine, so I will select both layers and duplicate it by selecting duplicate layer, move it to the side and select edit, transform, flip vertically, and then move it to the bottom. Now you can see that the 3D effect is kind of strange because we want the bevel on the bottom, so I will select this up arrow, copy, and move it 3 pixels to top to keep the same perspective. And just like this we have 2 arrows completed. Now for the left and right arrows, we can also copy one of those arrows and just move it to the right side and select edit, transform, rotate by 90 degrees. But we have to change the shape slightly because now with the perspective being applied, it should probably be a little bit wider and not that tall. So I will select the pencil tool and make it wider just by drawing some extra pixels in here and then filling this with white color. Then I will select the selection tool and select the upper half, select the move tool and move it by 1 pixel to the bottom and do the same thing from the bottom. So again move this, but this one to top, deselect, Ctrl D, select the eraser tool, which is this one, and maybe get rid of this pixel. And maybe I can make it even smaller by deleting more pixels like so. So I think that this might be a nice shape. Again, I will create a new layer and draw the outline using the pencil tool. And then use the selection tool to select the bottom half and again move it by 3 pixels to the bottom. And then use the pencil tool to connect those 2 shapes, and maybe I will make it a little bit wider like so. And I kind of like this shape, so I'll just make it more centered by selecting both layers and moving them closer to the original ones. And then duplicate those by selecting the duplicate layer, move them to the left side and select edit, transform, flip horizontally. And I think that this is a nice starting point, but we only have those arrows in the up state. We want the second set of arrows being in the down state. So for example, this arrow, imagine for the press state, we want to move it down like this and then change the outline accordingly. So I will group every arrow with the outline hitting the Ctrl G shortcut and give it some meaningful name. For example, button up unpressed, and do this with all the other ones. And then create a copy of those groups, again by right clicking and selecting duplicate layer. And this time this should be not unpressed but pressed instead. I will hide the unpressed states, and what I want to do is to move those individual layers by 3 pixels to the bottom, and then one by one select the outline, select the selection tool, and move the upper half by 3 pixels to the bottom. This is the down arrow, the right arrow, and finally the left arrow. And you can see that we have some extra pixels that we probably want to get rid of, at least for the left arrow and the right arrow, like so. And I'm almost thinking that those pixels don't have to be corner pixels, so I can just fill those in as well. Actually, I will do this also for the unpressed state. So now we have a set of images for the unpressed state and also for the pressed state, and we want to export those. But before we do so, it might be a good idea to keep the sizes of those images the same, just so we don't have to change those parameters inside our code. So to visualize what's going on, I will quickly create a new color fill layer, being some dark gray, so we can see the background. And then for all the unpressed states, we will create a new layer that will move below all the layers and select the boundaries of the image and then fill this with black color. So edit, fill with black color, hit the OK button, and so this will be the size of the icon. And then we will copy this layer and reuse the size for the pressed state. So if I move it inside the pressed folder, below everything, now this layer will force the image to be exported in this size. So I will do the same thing for every other image. Now with everything prepared, we can export those images, and there is only one change that we need to make to the images, and that is to change the group names to include a -e- in the name. So for every group, I will change this to a -e- and then the group name. Then go to the file, export layers, make sure that the format is set to PNG, and click the export layers button. And this is what we get inside the zip file. To turn those images into the arrays, we will use the image to CPP website, select those images, scroll down and make sure to check the swap checkbox, and then click the generate code. Now before we add this into our sketch, let's actually merge this image to OLED in 60 seconds with our main sketch. And we already have the OLED display in here, but it's not being connected to the Arduino. If I go to the image to OLED in 60 seconds, you can see that the SCL, the serial clock, is connected to the pin A5 and SDA is connected to pin A4. Now we have our Arduino board rotated, so those are those two pins, A5 and A4. But we actually also have access to those pins down here. So this is also pin A4 and this is also pin A5. So we can reuse those pins for the OLED display, which means that the SDA will go to pin A4 and SCL will go to pin A5. Then of course VCC will go to 5 volts and ground will go to ground. Now from the image to OLED in 60 seconds, I will copy those 3 lines, so including the UHG library for the display, also the wire for the I2C communication and the initialization of the display, and paste it up here. And then from the setup function, I will copy the UHG2 begin function and also paste it in the setup function. And from the main loop, I will copy all 3 lines. Again, paste it in our main loop before the delay. And since drawing those images will take some time, we probably don't need the delay anymore. Now this is trying to draw the image which is not in our code, but that's fine because we will now paste those generated images from the image to CPP website. So copy output and paste this in our code, for example, up here. And then just randomly select one of those images, for example, the EPD bitmap button down unpressed, and use it as a name for drawing the image. And I think that it was also showing me the size, which was 27 by 31 pixels. So I will change it in here as well. And for the position, for the X and Y position, I need to go back to Photopea, select this group, click the distances checkbox, and now I can see that the X position should be 49 and the Y position should be 33. So let's restart the simulation and see what happens. And we see a problem because we are including the UHG2 library in the code but not in the sketch. So I have to go to the library manager and click this plus icon and type in UHG2 and click this library. And hopefully now when I restart the simulation, it will not be showing any errors, which seems to be the case. And now we can also see the image being drawn on the OLED display. Obviously it's not reacting to the button, but we will fix this in a minute. For now, let's also draw the other 3 images. So I'll copy this 3 more times. And then this will be left unpressed, up unpressed, and right unpressed. And I will again show the Photopea window to get the positions and sizes. And upon restarting the simulation, I should hopefully see all 4 images, all 4 arrows, which seems to be the case, but there is something wrong with those images and they are overlapping and not displaying the other images, and that could be easily solved by calling this setBitmap mode to 1 to draw transparent images. So I'll copy this setBitmap mode to 1, paste it in our code and restart it one more time. And this time it looks perfect, so the only remaining part is to make sure that when I click the button, I want to show a different image on the display, and the different image being the pressed state of those individual images. Let's start with this down button, and I can say that if the state of the button, which is saved inside the button down state variable, equals high, that means it's not being pressed, so I will show the unpressed state. Otherwise I will show the pressed state. I will just comment it out up here and restart the simulation. And when I press the down button now, the image should change, which seems to be the case, so I will do the same thing for all the other buttons. And one last restart and we should see all the buttons working, so the down button, the left button, up button and the right button. To run this code on the real Arduino, just paste the code into the Arduino IDE. Now if you have never used the UHG2 library before, you have to go to libraries, type in UHG2 and install the library, and then just upload it to the Arduino board. And you can see that the display is connected to the Arduino UNO in the very same way as on the walkway sketch. For the I2C connection, you can use either the A5 and A4 pins or the dedicated SCL and SDA pins, which are in fact the very same pins, they just have more meaningful names. I've actually used the jumper wires because I was having a hard time fitting the OLED display on the breadboard. And so as I press those individual buttons, not only I can change the state of the LED backlight, but I'm also changing the graphics on the OLED display. After I've finished the tutorial, I've made one small change, and that is I've added the icons of those LEDs on the OLED display, being connected with the dotted line to those individual arrows. So now I can also see the state of the LED on the OLED display. I really like how those buttons look like, and I cannot wait to use them for my future projects. Something that I haven't mentioned yet is that you can remove the transparent cap and then put something inside, like a printed or hand-drawn label. You can also get the buttons with a different LED colors. We were using the white LED all the time, but I also have the red LED buttons. And I also have the blue LED buttons. And that's all for today. If you have any questions or comments, please put those down in the comment section. Thank you very much for watching, and I hope to see you soon. Thanks and bye.